The methods of hypothesis testing in this section are the same methods for testing a claim about a population mean from section 8.3, except that here we use the differences from the matched pairs of sample data. There are no exact procedures for dealing with matched pairs, but the following approximation methods are commonly used. So inferences about differences from matched pairs. Okay, the objective on the hypothesis test, we use the differences from two dependent samples, matched pairs, to test a claim about the mean of the population of all such differences. Number two, confidence interval. We use the differences from two dependent samples, matched pairs, to construct a confidence interval estimate of the mean of the population of all such differences. So the notation for dependent samples. Okay, D is going to represent the individual difference between the two values in a single matched pair. The mean, the population mean of the differences. This is the mean value of the differences D for the population of all matched pairs of data. This is the mean value D. This is the mean value of D. This is the mean value of the differences D for the paired sample data. S subscript D is the standard deviation of the differences D for the paired sample data. N represents the number of pairs of sample data. Now, requirements. Number one, the sample data are dependent, being matched pairs. Number two, the matched pairs are a simple random sample. Number three, either or both of these conditions are satisfied. The number of pairs of sample data is large where n is greater than 30, or the pairs of values have differences that are from a population having a distribution that is approximately normal. These methods are robust against departures for normality, so the normality requirement is loose. Okay, so for step one, we want to state the claim and the opposite of the claim. Step number two, we want to identify the null and the alternative hypothesis. The null hypothesis is the statement is assumed true until evidence indicates otherwise, and the alternative hypothesis is the claim to be tested. Now there's three ways to structure a hypothesis test with the differences. For the two-tailed, the left-tailed, and right-tailed, the null hypothesis is going to be the same. We have the mean of the differences, or the population mean of the differences, is going to equal 0 for the null for all three tails. Now for the two-tailed, the alternative would be the population mean of the difference is not equal to 0. For the alternative for the left-tailed, the population mean of the differences is less than 0. And for the right-tailed, the alternative is that the population mean of differences is going to be greater than 0. Now the alternative hypothesis is the one not containing equality. So the null hypothesis is going to use the symbol less than or greater than or not equal to. The null hypothesis is the symbolic expression that the parameter equals the fixed value being considered. Step number 3. We're going to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Number 4, we're going to select the significance level, alpha. Now, based on the seriousness of a type 1 error, we make alpha small if the consequences of rejecting a true null hypothesis are severe, and the values of 0.05 and 0.01 are very common. Okay, now the test statistic for a dependent sample with the null hypothesis being that the mean of the differences is equal to 0. So T is going to equal the mean of the differences minus the population mean of the differences divided by the standard deviation of the differences over the square root of n, which is the sample size. So finding the corresponding p-value or critical value. And so you always draw your curve and label. So for the p-value method, The p-values are provided by technology or using the t-distribution table A3 with degrees of freedom where degrees of freedom is equal to n-1. In the critical value method, critical values are provided by technology or using the t-distribution table A3 with the degrees of freedom being n-1. Number 7, making the decision. So for the p-value method, you reject the null hypothesis if the p-value is less than or equal to the significance level, and you fail to reject the null hypothesis if the p-value is greater than the significance level. For the critical value method, you reject the null hypothesis if the test statistic is in the critical region, and you fail to reject the null hypothesis if the test statistic is not in the critical region. And then number 8, you want to state the conclusion. So, for the first one, if the original claim does not include equality and you reject the null hypothesis, you would state that there is sufficient evidence to support the claim that, followed by the original claim. If the original claim does not include equality and you fail to reject the null hypothesis, then you would state that there is not sufficient evidence to support the claim that, followed by the original claim. If the original claim includes equality and you reject the null hypothesis, then you would state that there is sufficient evidence to warrant rejection the claim that, followed by the original claim. And if the original claim includes equality and you fail to reject the null hypothesis, then there is not sufficient evidence to warrant rejection the claim that, followed by the original claim. Okay, now let's take a look at the confidence interval estimate for dependent samples. So for the confidence interval estimate, the lower limit is going to be the mean of the differences minus the margin of error. The upper limit is going to be the mean of the differences plus the margin of error, where the margin of error is equal to the critical t-value times the sample standard deviation of the differences over the square root of n, which is the sample size. And then also the degrees of freedom where n is n-1. And so the procedures for inferences with dependent samples. Okay, number 1, you verify that the sample data consist of dependent samples or matched pairs, and verify that the requirements in the preceding information or slides are satisfied. Number 2, you want to find the difference for each pair of sample values. Number 3, once you find the difference, then you want to find the value of the mean of the differences and the standard deviation of those differences. And then number 4, for hypothesis test and confidence intervals, use the same t-test procedures used for a single population mean. Equivalent methods. Because the hypothesis test and confidence interval in this section use the same distribution and standard error, they are equivalent in the sense that they result in the same conclusions. Consequently, a null hypothesis that the mean difference equals 0 can be tested by determining whether the confidence interval includes 0.